Hello everyone and welcome back to ZakLiT educational channel. So in this video we are going to know the very frequently asked and most important concept coming in the environmental science entrance examination, specifically for the UGC net, in the pointwise note format. Yes, you should get ready with your notes so that you can write down these concepts. So without much delay, let's start today's video. So this concept is a very important thing. We will start with Bias-Ballard's law. Yes, what is this Bias-Ballard's law about the atmospheric phenomena? So here, what does it says? It says if we are facing our back behind if our back is towards the wind in the northern hemisphere of our earth, then our left hand will be pointing to the low pressure of the wind and our right hand will be towards the high pressure of the wind. I repeat, if our back is facing the wind direction in the north direction, then our left hand will be facing the low pressure and right hand will be facing the high pressure. So L for left, L for low pressure in the north region if our back is towards the wind. It is the trick to remember. Similarly, we should also know in the southern hemisphere what happens. So in the southern hemisphere, if we are facing towards the wind, as you can see in this picture, these two people, they are facing towards the wind. That's why there also left hand will be in the low pressure zone of the wind and the right hand will be in the high pressure zone. So this is in the southern hemisphere where the people, when they are standing and facing towards the wind. But in case of northern hemisphere, when we are having our back towards the wind. So don't get confused within these things. And here we will know that one important thing you should note down is what is cyclone and anticyclone. Where in the northern hemisphere, in the low pressure zone, that is the cyclone thing, and high pressure zone where it is moving in the clockwise direction, that is anticyclone formation. Similarly, coming to the southern hemisphere, what happens is the low pressure is moving in the clockwise direction. But as it is the low pressure, so that will be called as cyclone because of low pressure. High pressure, it is anticyclone, but it moves in the anti-clockwise direction. So here, I hope you have understood this thing. Here in the northern hemisphere, low pressure, anti-clockwise, it is cyclone. Because you should focus on low pressure. Where will be low pressure, there will be cyclone. Here high pressure, but cyclic movement, there it will be anticyclone. So as you have understood this, northern and southern hemisphere, these are the basic difference. Don't get confused. If you want to know again, you can pause the video and rewind. Let's move on to the next important concept. Next thing which we will know in this video is Wien's law, or it is also called as Wien's displacement law. So what it suggests, the definition is, as per the Wien's law, the wavelength at which a black body emits radiation with maximum intensity is inversely proportional to its temperature. First of all, what is black body? We all know that is a perfectly black body is a kind of body which absorbs all the light and reflects all the light. But in our universe, there is no such type of perfect black body existing. But we can say the sun is close to the perfect black body. I hope you have understood. So it is telling that wavelength at which a black body emits radiation with maximum intensity is inversely proportional to its temperature, to the temperature of the black body. That means wavelength, here we can see on the right hand side, wavelength lambda, that is lambda max, is equal to, that is B by T. So we can say lambda is inversely proportional to the temperature 1 by T. Or how we can do the equal sign? If we put a constant. So here constant is B. B is Wien's displacement constant. Its value you should note down, 2.897 into 10 to the power minus 3 meter per Kelvin. Why meter per Kelvin? Temperature in Kelvin and wavelength is in meter. So here sometime they will be also asking numericals. So if the wavelength is given, if you know the temperature, you should understand that the Wien's displacement constant is 2.897. You can take approximately 2.9 into 10 to the power minus 3 meter per Kelvin, where lambda max is wavelength of the maximum emission in meters of that black body, and T is absolute temperature of the black body in Kelvin. Here, let us focus on this left hand side graph. As you can see here, so here lambda max is there, here also lambda max, here also lambda max. So here, as you can see, ultraviolet rays, visible, infrared, all these wavelength have given. So when you can see here also 3 type of lambda is given, that means 3 different types of wavelength of the maximum emission. Here, as the peak is there, you can see here the intensity is more, because y-axis is this one, intensity it is showing, x-axis it is showing wavelength. So where the intensity is maximum, here if we draw this line, then the wavelength is low. But here if you see here what is happening, here the wavelength is more but intensity is less. Let me clear this thing. So here, as you can see, this dot, focus on this dot, x-axis is the wavelength, so it is maximum. But as the wavelength is more, it is inversely proportional to its temperature. So its temperature or intensity is given in this x-axis, so it is less. But here the maximum thing where the wavelength is less but the intensity is maximum, it is coming around 9 or 10, which is given in the units. I hope you have understood. Simple thing you have to remember, wavelength of at which the black body emits radiation is inversely proportional to its temperature, where B is the displacement constant, Wien's displacement constant, value is 2.9 into 10 to the power minus 3 meter per Kelvin. You can note down this. Let's move on to the next concept. Let me remind you about the 4 mock test series, which will provide a solid revision for the UGC environmental science paper. So this quality mock test, as per the latest syllabus, is available for just ₹199. Yes, 2 simple steps to avail this mock test. You have to pay ₹199 to this number 8895035690 and send me the screenshot, and then I will provide you the links for the all 4 mock tests. Next is Bode's law or Bode's law, sometimes you can call them. So Bode's law, also called TTS Bode law, which is given on the name of the scientist. It is an empirical rule or formula giving the approximate distance of the planet from the sun. Yes, from this formula we come to know the distance between the planet from the sun. As you can see here in this picture, this is sun. From there the planets are going towards from Mercury till Neptune. Here you can see the distance is measured here in the unit. So 0.39, 0.72, 1, 1.5, 2.8, 5.2, 9.5, 19.2 is Uranus. Earth you can remember 1, and you have to comment me in the comment section that what is this unit. Yes. So the formula, what it suggests that extending outward, each planet should be approximately twice as far from the sun as the one before. Yes, this thing is very interesting. What this Bode's law suggests? It suggests that almost approximately if we go from Mars to Ceres, so here what happens is, the thing is 1.5 is the distance from sun to Mars, but as we move on to the next thing, that is Ceres, it is 2.8, almost double the distance from Mars. Similarly, we can see here, for example, from the Mercury to Venus, 0.39 to 0.72, almost double. 0.72 if you consider 0.5 also, so it is almost double, that is Venus to Earth. So if you are considering from Sun to Earth is 1 and from Sun to Venus is 0.72 or close to 0.5. So what it suggests? Extending outward, each planet should be approximately twice as far from the Sun as the one before. So I hope you have understood. Here also one more example you will see. Saturn, 9.5 is the distance from the Sun, and if you move on to the Uranus, it is almost kind of double, 19.2. I hope it is new for some people. You should note down carefully. Let's move on to the next concept. So the next thing is forest cover classification. Yes, forest can be classified on the basis of different things. So on the basis of forest cover, It is based on the tree density. Yes, it is guided by the organization. They are setting this classification category, for example, by Forest Service of India, that is FSI. So the classification scheme for the purpose of forest cover assessment is described as follow. You have to make this table. These questions also come in the match the following or in the description type. Sometime it will be asked. It is also one of the very important question. You should note down what are the classes under the forest cover classification based on the tree density. One is very dense forest, moderately dense forest, open forest, scrub and non-forest. So what does the very dense forest means? So all lands with tree canopy means, here let us assume these are tree, not red color. So these are tree, the canopy means the top layer. So all lands with tree canopy density of 70% and above. So from the top if you see, the canopy are having 70% density in all the lands covering that forest, or above they will be called as very dense forest. I hope you have understood. Next is moderately dense forest. So all land with the tree canopy density of 40% and more, but less than 70%. So 40 to 70%, if the tree canopy is covering in any forest, it will be called as moderately dense forest. Similarly, open forest. All lands with tree canopy density of 10 to 40%. So that is the range, 10 to 40% tree canopy density, it is open forest. Next is scrub. Scrub forest, degraded forest land with canopy density less than 10%. Yes, which are called as non-forest. The lands not included in any of the above class will be called as the non-forest area. So these are the four important things. Less than 10% scrub, 10 to 40% is the open forest, 40 to 70 moderately dense forest, 70 and above very dense forest. So I hope you have noted down. So these were some of the important things which are frequently asked. I wanted to tell you in this video. So I hope you have learned something new. Don't forget to subscribe our channel ZakLiT for further updates. You can join our Telegram page if you haven't joined till now for the daily quizzes and prepare more efficiently. So see you guys in our next video. Till then, keep smiling and believe in yourself.